Good day, folks. This is tutorial number 21 called Wheel Rolling on a Cam, and it's part of the playlist which is called Kinematics on 3D Experiences platform. What I would like to do in this problem is to model this assembly, which is made of a wall or a base, a conrod, a wheel, and a cam, and this wheel is supposed to roll on that cam. Now, as far as dimensions is concerned, I'm not going to worry about that much. It's just that one thing I want to make sure is that the thickness of the connecting rod plus the thickness of the wheel is the same as the thickness of the cam. And for example, 0.5 inch, 0.5 inch, and 1 inch. And the reason is that at some point I will be doing a roll curve joint. And if for a roll curve joint, the two curves must be tangent to each other. Okay, so this is part of the activities that I'm doing to essentially upgrade this book, which was done about 9 years ago in the release 2016 X of the 3D experience. Okay, so let's go ahead and do this. I'm going to go to the platform right here, and I'm going to insert, right click, insert a 3D part first. So I will be doing the base. So let me rename this thing, properties. We're going to call this thing base, which is essentially my wall. And say okay, and let's go make it. Double click on the base so that I'm putting the part design. Let me see for a second. Yeah, double click on 3D shape so that in part design, on that vertical plane, I will sketch. I'll sketch a rectangle. This is about, I don't know, 11 inches, something like that. And then I'm going to draw a circle here. This is where the shaft for uh, the, the conrod is. And then another one down here, which is where the cam is going to go into. Okay, exit. Because I want to have, if I just pad this thing, I'll get two holes at these ends. I don't want to get two holes. I want to get the kind of a pin at the two ends. So I will be doing a multi-pad. And notice that in multi-pad, there are three curves. The big curve is curve number 3. You can see that right here. I'm sorry, the circle on the top is curve number 3. 1 is the big curve there, which is the rectangle, and 2 is that hole at the bottom left, or that circle at the bottom left corner. So, for example, let's say that I'll make the domain 1 or curve 1 point maybe 3 inch. Okay. Then the other one is going to be that pin over there. So that's number 2. Actually, it's down here. I'm going to make this thing, I made this thing 0.3, so I'll add maybe 2 to it. So it's going to be maybe 1.5 to it. So that's going to be 1.8. Okay. Same thing with this one, 1.8. All right. Oh, sorry, 1 point, yeah, I'll make it 1.8. I want this one to be 1.8 also. Okay, so remember, yeah, so there we are. Okay, all the way to the top. Let's do the connecting rod first. Right click, insert 3D part. I'm going to call this thing conrod, properties, conrod, and conrod. All right, let's go make it. Double click on the part, go into part design. So on that plane, on this plane, I will sketch. I want to project that circle, project this circle. There's the project. There we are. And then I will do the rest of the connecting rod. And the way I'm going to do that, of course, there's a million different ways of doing it. I'll use the elongated hole, put the center right there. And this is going to be my con rod. Okay. Now I need a hole at this end, so let me make a circle here. All right, exit and pad it. I'll make it 0.5. Remember I said 0.5, 0.5, and the cam being 1. Okay, so actually the direction of it I wanted to flip. So it looks nicer when you're making it right there. Good. Now, this is what's called a top-down approach. In other words, you create the part as you go along. Of course, the alternative is to go where you will make the part as needed. So let me go now. So what I did here is actually this connecting rod, then I'm going to do the wheel. So all the way to the top, make these things. Right click, insert. Oops, all the way to the top, right click. Where am I? Oh, I'm still in part design. Left double click. So that's your assembly design. Right click, insert 3D part. Okay, I'll call this thing the wheel. Where is this properties? Wheel and wheel. All right, let's go make it. Double click on the 3D shape so that you're in part design. On a convenient plane, why don't I make that plane perhaps this plane? Okay, and really doesn't matter, but anyway, so I'll sketch on it. I'm going to project that circle there. Okay, we'll do the rest of it now. Normal view. Let me go back to that sketch. Okay, good. Now the wheel itself is right here. This is going to be the wheel. Okay. And what I will do, I'll make an indentation here, a little circle there, so that you can see actually the rolling motion later on. Now, if I exit this, there's 3 curves here. Wheel has 3 curves. So what I'm going to do is I'll do a multi-path to make my job easier. Multi-path this. It tells you that there are 3 curves, and these 3 curves are the one in the middle is 3, the one outside is let me see, 2 and 3 are here, and 1 is this. 1 is that little hole. 1 is that little hole, which I'm going to leave it as 0. That'll be a hole actually. For number 2 and number 2. Okay. Let me see this one. This looks like it's number 3, so I will make this thing maybe 1. And this is going to be the shaft, of course. Actually, let me make it 0.7. And this is actually, which one is this? This one is actually, you can see it is the wheel itself. So let me make that in 0.5. Let's see how it looks like. I'm not sure whether this is what let me see. Okay, so let me hide that. If it's too much work, you can just go ahead and do it yourself any way you want. There is a shaft there. Is there a shaft there? Nope. Let's go back here. So that must be okay. So let me make this thing point. I don't know, 0.6. Oh, sorry, Okay, that was 0.5. That's fine, 0.5. Let me just check something here. Make this thing 2, see whether it actually, yeah, that is the shaft. So I don't want it to be 3. I'll make it 0.6. Maybe. Okay, good. All right. In fact, if I hide this thing, I can see that there's a little shaft there because that's going to go into that hole. Okay, so we undo this. There we are. So this guy is in hiding too. The Conrad is in hiding, so let me bring it in the front to see what I'm doing. Or later on, we're going to assemble that. Then we're going to insert the cam. Double click all the way on the top, right click, insert 3D part, and this is going to be the cam. Right click properties, cam, and cam, and cam. Let's go make it. All right, so we go to the cam, double click on 3D shape, go into part design. On a convenient plane, on that plane, for example, we will sketch. Okay, why don't I project that circle? There we are. Okay, so and now we're going to do the rest of the cam, which we'll clean it up in a minute. So perhaps okay. One thing I want to do is to make sure, first of all, these are tangent to each other. So this control that, go to constraint defined in a dialog box and make a tangent. You can see that. I'm pretty sure these are tangent, but just in case, maybe not. So this control that, again, tangent. Okay, good. And I want this thing to be concentric with that, just for visual purposes. This guy, control that to be concentric. Okay, good. And that's pretty much it. Now, what I want to do is a pad here for this. Okay, pad, exit, pad by 1 inch. I'll flip it so I can see it better. Okay, so notice that this is 0.5, that's 0.5. When you put them together later on, that should be 1. So this actually does not look like, are these 0.5? Let's go check it out. I'm not sure. Let me look at my Conrad, make sure that it is padded by 0.5. I might have changed, yeah, 0.5, that's good. And okay, this fellow, let me look at my wheel, make sure it is 0.5. Yeah, that is 0.5, very good. And make sure that this guy that I just made, the cam, is also 1. I might have forgotten to do a 1. Yeah, that's what it is. This is a 1. So those are 0.5, okay. Now you can see that when you add these up, you get the one that you want. Very good. So all the way to the top, all the way to the top. And let me collapse these things. All right, good. So first, I'm going to move these apart so that I can see it better. Here's a move, manipulate, translate. I'm going to translate in direction X. Okay, so that guy, this guy, and this fellow. All right, why don't we actually first, oh, one thing I want to do is I want to go and join these 3 curves. You may be able to do it without join, but I want to join it because I don't want to create a roll curve joint which kind of stops on that edge. It could be. So let's go back to the cam. Let me go back to the cam. And so let me go to the 3D shape and go to the, for example, you can go to generative shape design, or you can go to generative wireframe design, which is the baby version of a generative shape design. And there's a join icon here. So I'm doing it in the cam. So this edge and that edge, that edge, and that edge, I'm joining it. So later on, when I do a roll curve join, I'm going to do it between the join and that circle. Okay, so let's go back to the analysis, back to assembly. Okay, we're going to fix this entire base. So under the assembly design, under the engineering connection, you get the fix, and I'm going to fix the base. Okay, good. The base, did I do that? The base. Okay, there you go. The base is fixed. You can see that. Now let's put this cam inside of that, the shaft inside of that hole. So that's a revolute joint. I'm going to do a revolute between the different templates. I'm going to use this one, axis and axis, plane and plane. And because this later on going to be, for example, attached to a motor or something, I'm going to use the command right there, which is plane and plane, and we select the appropriate plane. So I'm using this template number 4. So let's go this axis and that axis, this plane and that plane. Okay. And for the angle, I'm going to control the angle between two appropriate vertical plane. For example, from the base, you can select, if you want, you can select XY. And from the cam, also XY or YZ, XY actually, XY or XZ. Okay, so I'll use XY. Good. And then do that. Hang in there. XY from the let me see now. Yeah, XY and XY. And say no. Okay, now we're going to do another revolute between this connecting rod and that pin. So another revolute, same template, between this axis and that axis, and between this plane and that plane. And say okay. And I don't need this because this is not going to be driven, so I'm going to delete it. So put the cursor there, left click and delete. Say okay. And no. Very good. Now let's put the wheel in there. So once again, a revolute. It can also be done with cylindrical, but I suggest revolute between this axis and that axis, and between this plane and that plane. And once again, since we're not going to be controlling that, left click, delete, and we say okay, and no. Okay, now what I want to do later on, I want to create a roll curve joint between this and that. Let me show you something. Let's go ahead and try to do roll curve. Now notice that here there is no roll curve. But if you go to engineering connections, under user define, if you go through the menu, pull down menu, you will be able to find the roll curve. You need to pick 2 curves. So I'm going to select this edge, and I'm going to select the join, which is right there. And then we say, okay, now these things right now, it gives you some numbers here. We'll come back to that later. You'll see why. Say okay and no. Now, if you update, you get this message. So what I'm going to do, I'm going to say, okay, fine, close this. Let's go back here to the roll curve. See that? This roll curve, remember I said we're going to go back to it? Double click on it, left double click on it. And instead of here, these values, change to unset and unset. And now say OK. And now go and update. No problem. Okay? So those things interfered with what we want to do. And I initially there were these values, so I went there and right click and did it unset, cancel. Now, first of all, is it working? So let's find out. We can check it out. We go to, what is that, manipulate. Make sure that you rotate make sure this is on, okay? So I'm going to click on this so that the constraints are on and rotate about the axis, about this axis, and look what happens. You see this? That's the way it should be, right? That's the way it should be. Okay. The only thing is that this fellow may not be long enough to be able to roll on the whole thing. I may have to come back and make this length longer, because by the look of it, if you look at this, that distance is not big enough. So let me cancel that. Go back to the cam. Go back to the two ways to do it. One is to maybe move this hole closer to that, or maybe make the cam longer. So let me actually go ahead and try to move this hole closer to where it was. It was on the base, right? It was on the base. Multipath. It was in the sketch. Okay. So let me take this and move it here. And exit. And all the way to the top. Update. Okay. Let me see for a second. Maybe that is, let's go ahead and move it a little bit. Move it back a little bit. Where is this? It was in the wall, right? It was this sketch in the base. Let me move this thing. Exit. Update. Okay, good. Let's check it out now. Let's try it again. Manipulate. Make sure this is up. Make sure the rotation about. Let's see if it goes all the way around. Yeah, you can see that. All right. So you have to be careful, because if this is short, then it's never be able to go far enough to be able to rotate all the way around. So that's fine. We'll just leave it the way it is right now. Let's do a quick save. All right. Now it looks on the surface that everything is like what I want. So now we're going to go and create our mechanism. I have not created any joints, any mechanism yet. Okay. So now we're going to go to where is this guy? Mechanical system design. Mechanism representation. Let's create it. Okay, good, good. Now, if you click on Mechanism Manager, there is some issue here. Notice that it's not an issue, but it's something that we don't necessarily like. Notice that here, this was angle driven because I made that. Remember when I was creating that Revolute, the first Revolute that I did? Angle driven? Remember those planes that I took at the end? It was option number 4, axis, axis, plane, plane, and another plane, plane. But because when you're doing roll curve joint, it also automatically it puts length driven. So uncheck that and say, okay, now when you click on this, see, it became green. Now, let's check it out. If you click on mechanism player, there's only one sliding bar, excuse me, sliding bar, and notice that if you drag it, it moves and it rolls, the wheel rolls. Okay. So reset. So basically, there's no physics here. I just, essentially I just move things around and it goes. I don't like these planes, so why don't we get rid of it? Control F. When I say get rid of it, means that hide them. Plane, find them, and then hide them. We get not responding. Ooh. Oh, just bear with me for a second. Ooh, I don't know whether I saved it or not. Okay, it did. Oh, gee. Save. Okay, let's try it again. Control F. That was scary. Plane. Find them and select them. And now hide. Very good. Okay. Now, now we're going to put some physics into it. But to put the physics into it, what you need to do, you have to go to mechanical system experience. Obviously, we already have a mechanism. Okay. All right. Turn this thing around so you can see it better. Now, we're going to put some physics into it, and how we're going to do that is here is the velocity, law excitation. It says, what is the support? The support is that command. That is the revolute joint, angle-driven revolute joint. I'll put a formula for it. Click on f of x. And for example, let's say 60 turn underscore, is that turn? Yeah, underscore per minute times time. That's one turn per second. Okay, that being the case, I'm going to create my kinematic scenario, select this law excitation, and for parameters, I put down 3 seconds. So it's going to, this cam is going to turn 3 times, 3 seconds. And I'll put down point, I don't know, 5 here, and then say OK. And finally run it. There's going to be physics there 3 times. Now, if you click on the play animation and change this thing, if it's too fast, you can change it to be smaller. Actually, what is that? 1, 2, 3. Okay, now keep in mind there is physics here. If you want, for example, you can say, all right, give me the velocity of that point, or give me the angular velocity of the connecting rod, etc. So yeah, that's pretty much it. The only thing that you have to worry about really going when you create a roll curve joint, I had to go and make those two values unset, and also for visual purposes, I wanted one sliding bar because this is going to be a single degree of freedom system basically. So I had to go and in this mechanism, if you go back here, let me show you. In here, the joints, I went there and I unchecked these things. Okay. Even if they're checked, it will work, except that when you try to do that manually, makes it control. There's 3 sliding bars. And they work, but I don't like the fact that these are checked, and I don't want to have one sliding bar when I'm doing on debugging. All right, folks, so this is it.